All right, so we're going to be talking more about solutions. We talked a lot about the behavior of liquids and solids when they are, pure. But what about when you have mixtures? So let's go to our lecture objectives for today. And so in this first segment, we are going to be talking about describing the types of solutions that can be created, explaining why solutions have a tendency to mix, and explaining which types of solutions tend to mix. Okay, so just to review, let's go over some terminology again. The majority component of a solution is called the solvent. This gets a little bit fuzzy when you have a lot of both. You could consider them both, you know, both solutes. The minority component is called the solute. Again, it gets a little fuzzy, but usually we're dealing with solutions that are primarily one thing and dilute in another component. Solutions form in part because of intermolecular forces. The intermolecular forces we've been talking about play a lot of role in when things mix and when they don't. So the particles of the solute interact with the particles of the solvent through these intermolecular forces. And it's the tug of war between who likes each other more, the solute interactions, the solute solvent interactions, or the solvent solvent interactions. So usually what we're interested in solutions is homogeneous mixtures. That's what we talk about when we say that things are truly dissolved. So a mixture of two or more substances, the composition may vary from one sample to another, but it appears to be one substance. It really contains multiple materials that are intermixed at a molecular level. So most homogeneous materials we encounter are actually solutions. They're not pure substances. They're solutions that are mixtures of multiple compounds. Air, air is a solution, right? Usually sometimes think of solutions as just in liquid, but you can have lots of different types of solutions. The air is a solution. It's mostly nitrogen with a large component of oxygen and then small components of argon, carbon dioxide, and so forth. So solutions occur between molecules of all phases. A gaseous solution, air is a solution mainly of oxygen and nitrogen. You could have a liquid solution whose solute is gas. For example, any sort of soda, you're dissolving CO2 into water. A liquid-liquid solution, any sort of mixture of ethanol and water is a liquid-liquid solution. You could have salt dissolved in a liquid. You'd have like seawater, for example. You can have solid solutions. So brass, which is a mixture of copper and zinc, is actually a solution because you've got copper and zinc that are intermixed with each other at a molecular level. So these are all solutions. The most common solution that we deal with a lot of the time, because it's important environmentally, it's important biologically, it's an important chemical engineering solvent, is aqueous solution, right? Here we've got an example, pouring some soda, and let's say it's club soda, so it's not too much other stuff. It's a solution of gaseous carbon dioxide in H2O, and some of that carbon dioxide comes out of solution forming the bubbles.